Hello everyone, in this video I shall tell you about the modified distribution method of solving a transportation problem in order to achieve optimality. So when you have the stepping stone method and the modified distribution method, the most preferred method is Modi method. So this is an example which has been taken up by me, and for more such videos don't forget to share and subscribe the channel. So this is a very frequent example that is seen in your exams. So we have is Ranchi, Delhi, Lucknow and Kanpur, and the capacity is 200 and 100 from Bombay and Calcutta, whereas the demand is 305. So since the transportation problem was not balanced, so in that case we've made it balanced by introducing a dummy row and with the capacity of 5. So now what we'll do is, before testing the optimality, I've found these allocations using the Vogel's approximation method. So if no method is mentioned, you have to use Vogel's approximation method for finding out the feasibility. So VAM for feasibility and Modi for optimality is the most preferred method, because they give you the optimal, in case of VAM they give you the feasible solution, the most feasible near to optimality, and Modi would give you a perfect solution. So these are the methods that are recommended. So now I've got the allocations and I'll check the problem for degeneracy. So the number of stone squares, m plus n minus 1, is equals to the number of stone squares, where m is the number of rows, n is the number of columns. So you can add the number of rows and columns. So it is 1 2 3 4 rows. We won't count the capacity and the demand. 1 2 3 4 5 6 7. So 7 minus 1 is 6, and the number of allocations, so number of stone squares means the number of allocations. So 1 2 3 4 5 6 is the number of allocations. So there is no problem of degeneracy. The solution, the problem is non-degenerate. So now moving with the Modi method, what I'll do is I'll introduce another column and another row in the same matrix, and I'll mark the row as Ri and the column as Kj, and I'll start with the stone squares. Stone squares वो होते हैं जिनमें allocation हुई होती है, और water वो होते हैं जिनमें allocation नहीं हुई होती. तो अब हमें allocation जो shift करनी है उसके लिए हमने स्टोन स्क्वायर्स देखने हैं, एंड एलोकेशन अगर एडिशनल करनी है तो हमें वो वाटर पे करनी है. सो आई विल स्टार्ट विद द स्टोन स्क्वायर. सो आई विल स्टार्ट विद द फर्स्ट रो, दैट इज बाय डिफॉल्ट. सो दिस इज 0. आई विल allocate 0 and I'll go to see a stone square. So the allocation, the cost is 90 over here. So in this case, the column and the row आमने सामने, the cost should be 90. So I'll mark this as 90 0 and 90, total ups to 90 and 70. So I'll mark this as minus 20, so that I get the total of 20. So minus 20 and this is 50, so this is 70. Now 70 minus 20, the cost is 50. So I have to look at the cost, not the allocation. So I have to do this procedure until all the allocations are complete. So in this case 0 and 100, so I require 100 over here. 0 and 100, I require 100 over here, and 100 and 0, so I require a minus 100 over here. मतलब आमने सामने की कॉस्ट मिला के आपकी ये वाली कॉस्ट आनी चाहिए. 100 and minus 100 would amount to 0. Now for the water squares I would check the cost. So the formula for that is Cij minus Ri plus Kj is for the opportunity cost. This is the formula for the opportunity cost. Opportunity cost means that whether the cost would increase, whether the cost would increase or decrease by changing the allocation. So I would find out that if the cost increases, I would not make the allocation. If the cost decreases, I would definitely make the allocations. So I would see in this case whether the cost increases or decreases. So 90 was the cost in this case, 0 and 70. So 90 is Cij, and Ri and Kj added up comes to 70. So the cost in this case is 20. The opportunity cost is 20. This means that the cost would increase if I make the allocation change here. So I won't do this. because I won't because in transportation problem the objective is to minimize the cost, not to increase the cost. Then for another watered square, which is Lucknow and Calcutta combination, Lucknow from here and Calcutta from here, 20 and 10 amounts to 80, so 130 minus 80 would be 50. Again the cost increases. Here again Kanpur and Calcutta, the combination is watered, so here in this case 80 should be deducted from 85, so this is 5. Again there's an increase in cost. Now I'm left with these Ranchi dummy combination, Delhi dummy combination, and Kanpur dummy combination. So in this case, so this is minus 30 and 70, so this is 100 minus 170, so this is plus 30, because 0 minus 30 would be plus 30. Again this will be 10, and 100 minus 100 would be 0, so 0 minus 0 is 0. So as you can say, in this case the cost is not decreasing at any point at any watered square where I can change the allocation or make an allocation. So this is the perfect cost. So I cannot reduce the cost by optimal solution, so I have to go in for the feasible solution only. So my feasible solution is my optimal solution, and there is no scope of cost reduction. How to calculate the cost in this case I would tell you in my next video, so stay tuned. Thanks for watching.